Hey everyone, it's good to hear, and it's been a while. I've uploaded a last video. I didn't well, I didn't mean to abandon it like that, but yeah, some things started getting in the way. Um, I'm a college student, so that took up a lot of my time for a while. But things started evening out now, and now I'm getting back into making videos again, and somehow I'm able to start back off where I left off, even though it was a few months ago since I did this. Or maybe a month ago. I forget if it was a month ago or not. Anyways, last time we got a working executable down. Technically didn't do anything, but, you know, it works a little bit. Today we're going to finish that up and having inputs, so we can actually do something with our program. We'll not be going over the file loading just yet. That'll be next episode. Since this does have a lot of stuff in it, I don't want to make the episode too long. Even the file loading will likely be pretty short, though. It's just, do we want to do it as int or char? Okay, without further ado, let's start. First thing we need to do is we need to actually read in the inputs. And we do that in here in our for each loop. Gotta move a few things here from my desk. And all we're gonna do is else if k equals w or k up. And what this will do is if we read in either w or the up key, either one, it'll do it. And it'll go through and do our command here, which is just gonna be ed app. No, don't need app. Content. There we go. Dot move. And all we're doing is moving our view. Now we're going to do it 256,000. It's going to move negative. And this isn't exactly how it's going to go. First we need to add in something else first, but for now we can put up the rest as a placeholder. A S D up, left, down, right, down we go positive, left goes to the left, so it is negative, right goes to the right. Now, doing it this way will be kind of awkward because it's going to jump. It's going very, very fast. So what we need to do is add in a clock. And we do that this way. I'm going to go to our editor. Wrong editor. Ooh. I gotta remember that these are the master list. I'm going to do editor.h. Now what we're going to do is, maybe right about here, we're going to do sf clock. And then, since in our main loop, the first thing they called is get events, that's where we're going to have a clock reset, so we can keep an accurate count of frame time, or seconds per frame. So we're going to go into our CPP file here, take out that breakpoint, and get rid of that tooltip. I hate that. And here in get events, before we do anything, we're going to do clock dot restart. And I'll be 1 second. Okay, sorry about that. Alright, now what this will do is, iframe will reset our count, and what we'll be able to do with that is, we'll be able to get the frames per second kind. Well, not really frames per second, but total amount of time elapsed in a second, or in a frame. So it's time per frame, which we use in our movement to ensure smooth, even movement. Because if we were to do it, like say, we'll assume this thing runs at 60 FPS. We can actually do that in SMO. We can set the frame rate so it guarantees to be at 60 FPS. Well, kinda. And we can do all our calculations around that, assuming that it's going to be 60 frames per second. We can make it so it moves smoothly. But what happens if you have a computer running it that has a lot of other stuff running it, and this goes at 30 frames per second? You have a different movement, and that could cause problems. So, we do a clock, and that'll ensure that it's even. Because clock will always be the same. So what we do for that is float dt equals, got a reference to our editor here, get elapsed time dot add seconds, and this returns a float, and it's what we use, which is why we have like this with the x0. Otherwise, it's way too slow. If we don't have it 2,560, if we don't have it like that, it's too slow. Then we multiply it by our difference in time. And now ensure smooth movement. Now, there's some other things. We're going to be able to click and put our stuff there. Because it doesn't do much if we can move, but we can't see what it is we're moving relative to. So for that, we need to make a mouse class. As you can see what I have up here, 2 mouse classes. This is everything we're going to eventually edit. Some of this we don't really need to edit, but it is some oversights that I did make on some previous videos that really help visualize things like borders and everything. Some really important stuff you're going to want in the tile editor. So, go ahead and make a new class. Right now from the background you can probably hear my dog. Let's call it mouse. Don't forget the guard blocks. I need to figure out a way to just make the guard blocks default. I've just been oh no, not include. I've been too lazy to figure that out, how to do that. Yep, very important, guys. Good practice. That. I don't care if it's too much typing, you type more anyways. Our mouse is very simple. All we need is int x, y, basically, those are our methods. We have our int XY, and we don't need to do anything special. We can have these public. We'll just, since we already know our code, we're not going to assume we're going to start messing with the mouse, and the mouse is going to be updated every frame anyways, so it's pretty safe. Do it like that. Our tick is just going to be on every update. It's going to reset our refresh our coordinates. Left click and right click just return the bool, depending upon if it's left or right clicked. And there is a way we can actually make this any we can say any supported SFML click and check for that. But you can do that default with SFML anyway, so there's not really any point, and there's no need for us in our mouse class since we don't need that functionality. Unless you want to add it in, go ahead. So let's define everything. First, of course, x equals 0, y equals 0. On every tick, we actually need a SF render window, and we'll just have that by a pointer. Call this app, and we do that because we need to tell SFML we want coordinates in relation to the window. We actually don't want it missing anything else. And I forgot to include SFML graphics. And so we do. Actually, we're going to do this in a slightly different way. Since this is the way I kind of do it. You can do it either way, but so yeah, scratch that. Just do vector 2 pause. Since this is the most direct, straightforward way of doing it, and we can split them later on as we need either one or the other. We actually don't need this then. Kind of. So position, pretty much, it's going to be SF mouse get position app. And make sure to whatever you call it, access or dereference or whatever that calls, and you do that to the pointer, so it actually passes in the proper argument, and we can just return as normal. Next, we want bool is mouse is left clicked. Please return SF mouse is button pressed. SF mouse left. Pretty simple. And then if we want for right, voila. And now our mouse class is fully implemented. Nothing else we need to do with it. We can now go into our editor, where the heck we want. include mouse.h. Oops. And we're gonna implement a instance of our mouse. And we can do that just right down here in the bottom. Mouse. Now we're going to our editor. That's not. Oops. Not where I wanted to go. Not in tick. Oh, yep. In tick, editor.tick, we are going to, since our mouse is part of our editor, there's no need to have it anywhere else as far as updating goes. It ticks on every editor tick right before we do process inputs. And we pass in app directly to it. Now, as we go into state, no, that's not it. Well, the way we're going to tackle this is there's going to be multiple cases of what we do where we click, and we can do that inside here. There's a couple of clever if statements. The first thing that needs to happen is we need to determine if you clicked at all. So if ed dereference it stat is left clicked, go down if statement level. Else if ed mouse is right clicked, go down a level. Then we want to do another if statement. If our mouse is clicked and we are less than 64 pixels from the right or from the left, then we're going to do something differently than what we would do. And these positions, keep in mind, they're not relative to our view. They're relative explicitly to our window coordinates. That's going to become important kind of later. If we're in this case, and actually it might be better to have a curly bracket here, curly brace here. Then I don't think we implemented it yet. We're going to set a selection on the side panel. We're going to set a selection to that. Now, before we continue on this, we need to actually go implement that real quick. So we're going to open up tile list. Here we have top tile. We're going to have an int selected tile. And this is going to be the tile we use to draw with. For that, we need some getters and setters. So void set selection. Void get selection. And it's not a void, but it's an int. And we're going to do this, call it selection, just for uniformity. Now we're going to go ahead and implement some other things in this while we're in this class. We're going to make two rectangle shapes. Call it boundary and select rec. Call it boundary rec maybe. That way it's more obvious what we're talking about. This is important because it helps distinguish where our tile list is, you know, what not to click, because it's going to be click based on what you select. And I noticed that when I didn't have it, it was way too easy to click and change what you had selected, and you didn't know necessarily what you have selected. So it's important to have this kind of stuff when we're dealing with a tile editor. And it's that kind of stuff that may come in later on that you might think, you know, you need to do it. And it's a good idea to put it in here, just so you don't break anything. It's inside the class, so it's not breaking anything, nothing you need to change a document for. At least not with this kind of low-end stuff. With more professional software, it might. Now enough of that tangent. Okay, we're going to do this all at once. So, selection defaults to 0. Boundary rec equals SF rectangle shape, SF vector 2F. It can be 64 by 600. Just some hard coordinates. They would really be the size of a tile for width and then the height of your entire screen. Select rec, same thing, except it's just 64 by 64. And then some important initialization code for these two things. And copy this. Oops. This sets our set outline thickness, and we're going to set it to 10. Set fill color. So color. And what we're going to do is we're actually going to make it 255, 255, 255, 0. And the 0 here means it's fully transparent. And I put it to white just in case, you know, we mess something up and we want to be obvious. Okay, this isn't proper, because I was getting it's easy to make an error with that, like setting it black, and then you accidentally set the transparency to fully opaque, and you don't realize. You think it's empty, but you realize, you know, later on. Oh wait, no, we're actually, guys, I'm showing you up that we shouldn't have showing up. Certain things like that. And we're going to set the outline color to we'll set the outline to green. How about that? Green's a good color. And we don't need a third argument. It's going to be assumed to be 255. Or actually, no, we do. We want that to be 100, actually. We want it to be somewhat clear just for the looks of it. And we'll do the same thing for the select rec. Just copy it. Copy and paste is your friend, my friends. But instead of green, we're gonna make it blue. Next, we need to implement our set selection and git selection. Oh, undefined. That's why. Oops. Been doing that all day. Alright. So we're gonna do an if statement. Just make sure our I is out. If I is greater than or equal to 0. And I is less than s-list dot size, since you know that's our total number of valid selections. Selection equals I. Return. That's everything for that. Now, we do one last thing for our draw. First, we always draw our boundary rect, and then if our selection is on the screen, because you know we have like this paging code right here. If it's on the screen, then we can work with it. So if selection greater than or equal to top tile and selection is less than top tile plus 10, then we draw a selection rect. And that's everything about how we get a selection. And actually show, you know, okay, yeah, this is selected. So coming back to our state, ed t list dot I'm going to set our selection to our mouse position, y, divided by 64. And that will work just enough for what we need for this. That will work perfectly for what we need for this. Else, we are in another valid way. And what we do here is a bit more complicated, because this is where we're actually drawing. It's not enough to just do what we did here and just draw directly with the mouse. We also need to add in a little bit other code, but it's relatively simple. I'm trying to remember what I wrote here. I know what to do, but yeah, that's one of the difficulties making these kind of videos. Keep doing brain farts. Map the editor. And then it's going to be take three arguments, or x or y, and then what tile we want to edit, what tile we want to place in those coordinates. We take our x, we add, that's important, our content view dot get center dot x minus 400. Okay. We're going to do this again, except now it's going to do 300, and we're going to have them for y's. And then we replace it with ed.tlist.get selection. Now let me show you what this is that does it. Our window. Let's imagine this black square right here, this darker thing, is a window. Okay. We could have the view set 0, 0 right here in the center where mouse is. But what our mouse position will get is relative to the screen, not to our view. So this up here will be 0, 0. This in here will be 300 by 400. Now, if I wanted to draw right up here, but I move the view, like I have here, to where 0, 0 now, at this exact area, if I click up here, it is technically minus 400 by minus 300. And so I must use my mouse position, add the center, which could be, in this case, it would be moved to the right and down, and subtract half, so it comes to the proper point of where I'm drawing. And one last critical step, take all that, divide by 64. This ensures that it takes whatever coordinates we have, and it'll give us pretty much which tile we are on. Now we're going to edit this. We have our right clicked, and we're going to do this both in one, since there's only one thing we're going to be doing with this. It's going to be and ed mouse.pause.x is greater than or equal to 64. It's different. This makes sure we only need a right click within our content area, not along the side. And this is similar, except instead of editing with what selection we have here, we're going to place a -1. And all that means is we're pretty much taking whatever we had in there and we're erasing it. Alright. Now, let's see everything we did here. Click flags, restart clock, mouse handling, mouse instance, every time, process the camera, mouse handling. That should be pretty much it, with one exception. And you see I have a certain tactic of how to work with this. We need to change the map because there was an oversight I had that was very bad. Very bad. I should not have done it like this. And this is entirely how I have it here. What I have it right now is I have a list of sprites and I'm setting their position, but there's only one sprite per kind of texture. So that would mean that as I'm setting position, I'm setting the position multiple times for one single sprite, and the last position that it has is the one getting drawn. It's not getting drawn in all the other positions. I need to do that as, right here, as I'm drawing it. Now, we can't do it just yet like that. We had to change something first. So we're going to go into our map.h. You can go ahead and get rid of pre-draw. We do not need it anymore. Don't delete it, but we don't need it. We're going to take our draw function, and we're going to delete this constant reference. And we're going to make this draw function public. And we can go ahead and get rid of the render states. And we can even change this to render window. We'll go ahead and make it a pointer, since we tend to work with pointers anyways. Now, we're going to go into our map CPP, change our entire draw code. For one, we're going to take this, take that out, take that out, take the constant out. That's the most important part, take the constant out. Though everything else could work without changing all this other stuff, you just need to take that constant out and make this thing public. I don't know if you remember why we had it this way, but we can't modify anything under a constant function. And here we need to modify stuff as we're drawing it. Very important. We're going to take this line of code, and here we're just going to paste it right there. And then you can get rid of pre-draw. And that should be it, with the exception of one last thing. We need to go into our state, get rid of this here, and we need to draw. Can't draw map. We actually do need to take this out since it no longer inherits. And we need to do map ed map.draw app. And say start a project. Yes, we want to build it. And we'll see the moment of truth if it actually worked. Should work. Unless I forgot something. And I did miss something. I forgot a colon. Where did I miss that colon? Nope. Ah! And I think that's pretty good. Doing all that change, about an hour's worth of video, I think so far. One error. And there is one last thing I've also got, and something just happened. I have no idea what happened. What is that just happened? Okay. Vector substitute out of range, so something's going out of range then, huh? That's usually something to do. I didn't have that problem up here. It's something to do with oh yeah, that. But there's something that does need to be implemented regardless. Go. Let's see here. There's nothing really too different about these two, except that I have What do I have different here? I have something different here. Weird. Yeah, I have that. That's the only code I have different in my master. I don't know why I didn't implement that here. It would have been a good idea, but oh well. We need to add something for a boundary for our entire map. So we're just going to do rectangle shape boundary. Come up into our map. We can go into our tile list, pretty much copy everything out of here. Call this map boundary rect. Make it width times 64 by height times 64. 15. And then we draw it. Oh, something isn't working quite right. Something isn't working quite right. That should not have happened. I wonder what happened and what changed. Okay. Well, for one, I don't think this should be an or. That should definitely be and. So in map.edit tile, change that. Actually, I have a completely different way of doing things up here. Don't know quite. Ah! Yep, this still works. Okay. And then we'll try that again with that change. Yep, there we go. Now, for some reason, my selection doesn't quite... Oh, wait, no, I know why. I know why it doesn't change. We haven't put the code in that, but I'll go ahead and fix that. Right after we figure out why this camera is so shaky. Okay. Let's go back to, we can close most of this now. We don't need you open. We don't need you open. State here. Do our clock that give less time, that is seconds. So let me jump into my code real quick, my main code, and see how I did it, which is exactly the same here. We did it as a float. So let's go into our editor, CPP. In the beginning of get events, we do clock at restart. That's what I do here. It should be everything, but apparently it isn't. Answers on a postcard? Okay. Oh, time to go look in my documentation here. We do that. We add clock handling. Okay. And then we do restart clock here. We did that. So let me see if it is actually something with that and go to my directory real quick. And I can see all my stuff here. Where is... Oh yeah, here we go. What is somewhere here? Try the master. You see how it handles here. You see all that. That's how it should be handling. And I see what happens here. I didn't quite set that properly. Okay. I did it for 256, right? Yeah. Times DT. Times DT. Can't quite think of what would cause news like that. I will pause this for a second and come back to you with what I found. Okay, well, I spent about an hour looking through all this, and yeah, I have no idea what it is. I have determined that when we run it, it seems to speed up whenever I move the mouse. I can't determine how this behavior is exactly working, but I have no idea what it is that's causing the mouse movement to be changing, something like the frames per second kind of stuff. Yeah, so anyways, there is something I can do here that could check. I'll go to my state of CPP, and this should work. I don't know if it will, but I could output over dt. That should give me the frames per second. Causing some pretty severe. Moving the mouse is causing some pretty severe frame rate drops. I have to say. So what I might do is we'll take this. We'll go into our editor. I forgot how to force the frame rate, but we can do that. So app set frame rate limit set to 60. No, still, that causes some pretty. That's not the right frame rate. Okay. Well, I guess that's all I have to do for now. This video already got time long. We do have a technically working version with just a major bug. I'll try to see what it is that bug is. It's not in here. I copied this verbatim out of my my main version, and it worked. Oh no, it didn't work. It had the exact same problem. I tried doing it with everything, and still was having the same problem. So I have no idea why it would do that. But it does seem like moving the mouse has some effect. So I don't know what would cause that though. Anyways, from the next episode, if it's not about this bug fix, which might be just if I do get it about this bug fix, it'll just be like a, I think 6.5. The next full video will be file loading. That's all we have to do, literally. Once we get file loading done, then that's it. What we have for this tile editor, and this is guaranteed. As long as it's the full video. If it's just a 0.5 video, then that's our fix. Alright, so if you like this video, even if we have a semi-working exe, sure to like, subscribe, and comment. Comment more than all. Just say. And yeah. Beyond that, this is Skippy, and hope you enjoyed this video. Thank you for watching.